Okay, the mission in this question is to find the distance of the yacht Y from the port X. So let me just read you the question. A yacht is located at Y, there it is right there. There are two ports 180 kilometers apart. Now they're located at X and Z right over there, and Z is exactly east of X. The bearing of the yacht from X is 43 degrees true north, 43 degrees true north to the yacht, and from Z it is 302 degrees true north to the yacht. So we got these angles there. We have this one distance. Our mission is to find how far the yacht is from port X. So how far the yacht is from port X. So we're looking for this distance right over here. So let me just mark it out. Looking for that distance. That's the unknown. So let's find that. So the first thing we want to do is mark up what we do have. What do we have? Well, we have this triangle here, and we have the distance between it of 180 kilometers. Now we have bearings of 43 degrees and 302 degrees true north respectively. So I guess if we want to find this distance here, we need to find some internal angle so we can use some sort of trigonometry in order to work that out. So let's see if we can find some internal angles. Well, we got here a right angle here. It's a right angle because we know that Z is east of X. So if it's east and that's north, that's going to be a right angle, 90 degrees. And if we work out the complementary, in other words, the complementary of 43 degrees, we can find that angle there. How does that work? All you have to do is go, the whole thing is 90, take away 43, and that'll give us the missing angle right in there. So let's go ahead and work that out. So there it's going to be 90, the right angle, take away 43. That's going to give us the missing angle right in there, X. So that's going to be 7, 9 minus 5 is 4, 47. So that's going to be 47 degrees. 47 degrees there. That's the angle X, 47 degrees. We have that. Now let's go over here and see if we can find this internal angle right here. Let me just mark it up right there. How do we find that? Well, we have the true north bearing clockwise. The angle is bearing all the way around to that point right there. So how do we work that out? If it's all 302 degrees, all we have to do is take away the 270 that goes up to this east-west line right there. So it's 90 plus another 90 is 180 plus another 90 is 270. So that point right there is 270 degrees. So clockwise to that point right there, 270 degrees. So let's subtract 270 from 302. Let's go ahead and do that. So 302, take away 270. That's going to give us 2 minus nothing is 2. 10 minus 7 is 3. So it's 32 degrees. So that angle there is 32 degrees. We've got two internal angles. How do we find this angle up there? The third one? Well, we know angle sum of triangle is 180 degrees. So we add these two guys up and take it away from 180. Let's go ahead and do that. So that's going to mean it's 180. Take away 47 and 32. Now 47 and 32, what is that? That's 9, 79. So that's going to be 79 degrees, so 180 take away 79. That's going to give us an angle of 101. 1 degree. So that's the angle there, right there at Y. So Y is equal to 101 degrees. Let me just put it in there. 101 degree. Okay, we've got more information in this triangle now. As we said earlier, we've got one distance, 180 kilometers, and we have all the internal angles. Our task, our mission, is to find that length right there. So how are we going to find it? Well, I think what we can do is notice that we've got an angle opposite a length. We have an angle opposite an unknown length. So when we're working with things like that, that across that, that across that, it means we can use something called the sine rule. Here it is right over here. Just x, which is the distance, over sine x, the angle, equals y over sine y, the angle, and the distance z over sine z, the angle. So what do we have here? So if that's big Z, let's call this big Z, that's the angle 32, then this is going to be little z right here, or little z. So let me just fix this up there. Okay. So we have a known angle with a known length, known angle, unknown length. So we've got 3 knowns, 1 unknown. So let's use the sine rule to actually determine what the length z is, which is between x and y. We want to know how far the yacht is from port x. So let's use sine rule right here. So what do we know? First of all, we have the 101 degrees and the 180. So we know that. So let's work with that. So that's going to be y on sine y. So that'll be 180. Actually, let me write it down as y on sine y so it makes more sense for you. Y on sine y is equal to z on sine z. Now, what do we know? Well, what we don't know is this z. That's what we don't know. We know this, we know this, we know that. So let's substitute in there and work this out. Okay, so let me just put a little border here. Okay, let's work this out. We have y. Do we know what the length y is? Yes, it's 180. So that's 180 over sine y, which is sine 101. 101 degrees equals, okay, z, we don't know what z is. That's the unknown. All over sine 32. And just put that there so we've got a bit of space. So now what we do is we cross multiply. So 180 times sine 32. 180 times sine 32. And then we divide it by sine 101. 101 degree. So that's going to give us the length of little z. Okay, so multiplying 180 times sine 32 divided by sine 101 on your calculator, that's going to give us that distance there, z. That's going to be to 2 decimal places. So little z, the distance equals 97.17 kilometers. So right there, we have the distance 97.17 kilometers. So the distance in this diagram along here, the distance that the yacht Y is from the port X, again, is 97.17 kilometers. There you go.